This is a quick slideshow of the construction of the robot. I used some gearing to slow the motors down. I only drove it with 2 motors, didn't need that back motor. I just used it as a free spinner to balance out the weight of the robot. This is the building of the chassis. I didn't actually decide to invert it until I was completely done. So you'll see the chassis built right side up. And then you'll see in the final design here, the chassis is actually inverted and everything is mounted on top of that inverted chassis. Battery mount on the side, it's similar to the first robot, but a few things are moved around to fit the sensors in there more cleanly. And then the sensors are mounted right on the front there so they can see the lines easily. I just want to quickly go over the few of the design aspects that I was running through whenever I started making this robot. I went with a 3-wheel design because I like the simplicity of it. I used it in my first robot project because it's easier to control and it seems to get around easier. It doesn't drag the wheels as a 4-wheel design would when you try to take turns. And the basic structure of this is almost exactly the same as it was for my first robot, except as you'll see here, I've actually inverted the chassis. The chassis is built upside down, and then the second tier platform is built on top of that. But the actual chassis itself is built upside down. And I did this to give me better attachment points so that these sensors came down to the right height to be right against the ground but not touching the ground. This was originally to give me better control over what's going on because of the way I had the wheels set up, but I ended up not needing that, but it ended up working out because of the way I had the sensor set up. But the basic design is just a 3-wheel chassis, 2 standard wheels in the front for your basic turning, and then just a free spinning omni wheel in the back that keeps the balance, keeps it from dragging the robot, but allows it to only stand on 3 wheels. I went with this design because less parts equals less things to go wrong, and overall it makes it much more stable and cleaner when it goes around the track than it would if it was a 4-wheel design. Okay, so this is the code running the second objective of the line tracker robot. The second objective and the first objective are essentially the same code. One is just counting while the other one is not. The first objective will run infinitely, just running the track, following the line over and over and over and over and over again. Whereas objective 2 will actually count the crossbars and tell it when to stop based on how many I tell it are on the course. So we begin at the top with our LCD setup with the new Arduino Mega board. This is required because of the way the new Arduino is set up for it to work. We set our integers. I set up a bunch of integers for speed so that if I needed to change something, I could just change these numbers instead of changing each one of the if statements below. I also set up an X variable for the counter so that I can just have a variable set up for me to reference later on if I need it whenever I want to start counting the lines to go around the track. Now, setting up, we start with the usual LCD, begin setting the origin of it, turning on the backlight, and then we move down to the actual meat of what we're using the LCD for. I'm doing the usual, using my name and telling what the project is that the robot is currently working on, or I'm currently working on using this robot. And then below that I've used the bottom 2 rows to show me what the values are reading out for the sensors, as well as what the line count is, so I can tell whether it's accurately reading those cross lines as it goes throughout the course. I then tell the Arduino where the motors are attached, as well as give it a place to look for those sensors. As we move down, as we finish up with the setup, we move into the loop function. Now, there's a couple different ways you could have done this for making it count. Or stop when it counts the lines. I did it with an overall while statement. So while x is less than 4, there's 3 lines on the course. I started it behind the first line, so it actually crosses 4 lines. so it stops right back where it started. And I could have done this with starting with an if statement or if else statement, or else if statement, sorry, and having each one of these be anded as well with a x is less than 4, and then saying that else if x is greater than 4, stop. But instead I decided to put everything else in a while loop except the stop function at the end. So once all of this is done and x is greater than 4, it'll kick out and stop and will not go back into that while loop. This just saves a lot of lines of code, a lot of typing, and makes it much easier and simpler to tell the robot what to do. So we start by initializing the sensor values, telling them where to read, where to get them, that they are analog values. I'm then printing each one of those values into what we set up above in the LCD setup to show what those sensors are doing. It'll give me a 3-digit to 4-digit value between 0 and 1024. I can set those thresholds, and I can use that for debugging and calibrating whenever I want to tell what threshold the line needs to be set at. So those are the first 3 setups, and then the last for the LCD, it's printing the X value. And this is in the loop because I want to always see what the X value is when it changes after it goes through these if statements. That way we can tell if it just keeps running after it hits the 4th line, whether it is actually sensing the right amount of lines at the right times. We then move into the meat of what's actually controlling the line tracking. And this is done by a series of if statements, beginning with when only the mid value is high, or black, because black outputs the highest number, we drive forward. Now I made this relatively slow. I set up a integer called quarter forward, quarter speed forward. I just took the ratio of what the full speed is of these motors, scaled it down to a quarter, and used that number as an integer above. I did the same thing with quarter reverse. It just allows it to be relatively still pretty quick going through the course, but in control while it goes around. So in the first if statement, if only the middle is black and the outside ones are not, or there's something else, then you just drive forward. Next is if the left is black, but the middle is not, and right is something else, the left motor, it'll correct itself so that the left motor will pull back a little bit while the right motor pulls forward a little bit, turning left for you to correct. The right thing is the exact same thing except reversed for the right side. And then I actually added this safety function in here just in case that the right value and mid value happen to hit at the same time, to keep it from freaking out at the end whenever it thinks it's seeing all 3 of them. So what I did was set up to where if the right value and left value, it does the exact same thing as if just the right value. Or if the right value and mid value are high, it does the exact same thing as just the right value. And the same thing if the left value and the mid value are high, it does the same thing as just the left value. And then I added another safety function as I noticed that when I was running this, once in a while the robot would either get confused or not be quick enough, and then the sensors would be wrong because it would just run right off the track. So if it overcorrects itself a little bit and it gets off the track, I have this last function in here that if all 3 of them are something besides black, back up until you see a line. So it means that it's over on the track, it's not reacted fast enough to its own readings, and it'll back up until it sees a line, and then it'll start back on the course the way it works. This actually works pretty well. I've had it over on a couple of the corners. It just pulls off, backs right back up until either the left or right hits that black line, and then it goes back to doing its thing. This last value is to give it something to do whenever it hits that line besides just count. So what this does is whenever all 3 of them are black for sure, not just greater than 80 as I said before to make corrections, black for sure, so above 500. I just had it drive straight forward, give it a delay so that the counting doesn't become infinite, because otherwise as long as that is high over that black line, it'll count every millisecond and add 1 to my X, which was a problem I ran into. So I figured it out around 3/10 of a second was pretty good to make it to where it only counted once for it to be all the way across the black line. So I just added a little delay in there for it to drive straight forward when it hits that line, and add 1 to the count, wait 0.3 seconds, and then check it again. If it's black again, it will still add the line after that 0.3 seconds, but it does do a pretty good job. And then, like I said, once it kicks out of that while loop, after the count is 4, it'll just stop and sit there, just like I told it to.
You can start on Friday. Now, is that turned sideways when it's responding to the hash mark?
What's that?
Probably.
So I will let you get away with that with objective 1, but objective 2, that's got to be fixed.
There is actually a term. It's like a current dash line, but yeah. Let's see what it does here.
So here you can see the LCD integration. Right now it's sitting on top of the black line, where you can see the midline is high while the other two are low. As we move it over, the left becomes high, and you can see that the right becomes high on the other side. And then if I push it forward here to get it over a cross line, you'll see the X increase for every 3/10 of a second it's on that line. So pull it back, get the thing ready, push it forward over the line. You'll see the screen come into focus. It's 0, 1, 2, 3, because I left it over there for probably a whole second, and then it goes forward on its own.